The main idea of the chapter is to measure the length of one degree in order to be able to measure the circumference of the planet, which resulting to measure the size of the whole planet. Pierre Bouguer and Charles-Marie de Condamine led an expedition in 1935 to triangulate distances through the Andes. The goal of the French party from determining the circumference of the planet by measuring the length of one degree of meridian along many cities was to understand the Earth. Many quarrels and negative events happened between the French group which led to suspend the work for 8 months. Besides, officials were suspicious of them. Why would they travel halfway around the planet to measure the world when they can simply measure it from France? The answer is that if the French found an alternative available, they wouldn't do their work simply. Edmund Halley, Robert Hooke, and Christopher Wren will wonder about why the planets are inclined to the orbit in a particular kind of oval. Wren offered a prize to whoever knows the solution, but no one knew, so he went to Newton, who produced the mathematical principles of natural philosophy. His principles explained mathematically the orbits of heavenly bodies and the gravity, which is the attractive force that moves these bodies. Newton also created the three laws of motion, which are: things move in the direction it is pushed, things keep moving until something slows it, and every action has an opposite and equal reaction. In addition, he formed the law of gravitation, which is that every object pulling every other object around him, and vice versa. Newton is the one who realized that if the distance between two objects doubles, the attraction between them becomes 4 times weaker. According to Newton, the theory of the shape of the Earth is an oblate planet because of the centrifugal force of the Earth's spin that results in a slight flattening at the poles and bulging at the equator. So the French group would not be able to measure the circumference of the planet as they thought that the Earth is a sphere. Norway calculated the length of 1 degree, which is 110.72 kilometers, by starting with his path against the Tower of London and marching 208 miles north to York, and then he measured the angle of the sun at York on the same time and day of year he started in. Jean Picard depended on the belief that the Earth is a perfect sphere to measure the length of 1 degree, 110.46 kilometers, which is more accurate than Norway's calculations.
Newton hypothesized that a plumb bob hung near a mountain will move slightly towards it affected by its gravity. Based on this, we can get the mass of the mountain, the constant gravitation force, and the mass of the Earth. Years later, Neville Maskelyne realized that this experiment must be done in a regular shaped mountain to get accurate measurements. Maskelyne was helped by Charles Mason, an astronomer and surveyor. Maskelyne and Mason were old friends since they were engaged in an important project, which is measuring the passage of the planet Venus across the face of the Sun, because years before, Halley suggested that if they succeeded in measuring this passage, they will be able to measure the distance between any two bodies in the solar system. In 1761, the scientific world was ready for the event. 18 British observers were sent everywhere, to Siberia, China, South Africa, and many other places. But unfortunately, this event was considered one of the most unlucky projects, and the observers faced a lot of problems, like wars, sickness, or the damage of their equipment, and the transit observation was considered a failure. But one accurate measurement was taken in 1769 by a young sea captain named James Cook. As a result, the distance between the Sun and the Earth was measured as about 150 million kilometers. In 1772, Mason and Maskelyne found the perfect mountain somewhere in Scotland, but for some unknown reasons, Mason has left the project, but Maskelyne did not give up. In 1774, he, along with a team of surveyors, went to the Scottish mountain and took hundreds of measurements. On the same time, a scientist called John Michell had invented a machine measuring the mass of the Earth, but he died before operating it, and his invention has fallen in the hands of Henry Cavendish, a British scientist who improved the machine and finally measured the mass of the Earth as 6 million trillion metric tons, which is only 1% different from today's measurement.